Class 10th, chapter number 10, circle. From a point Q, the length of the tangent to a circle is 24 and the distance of Q from the center is 25 centimeters. The radius of the circle is. This is your circle. Point Q is outside and the length of the tangent to the circle is 24. This is your tangent and its length is 24. And the point Q, its distance from the center is 25. You need to find this length. Radius. One thing you know that the tangent is always perpendicular to its radius. Okay. Now it is your right angle triangle. If it is your right angle triangle, you use Pythagoras theorem. This is hypotenuse, this is this, and this. Perpendicular equals to hypotenuse square minus base square. You will get here 7 after simplification. You do this question in this way. Now question number 2. In the given figure, if TP and TQ are the two tangents to a circle, okay, TP and TQ are the two tangents with the center O. Angle POQ is 110 degree, then PTQ. You know this angle is 90, this angle is 90, 90 plus 90, 180. So this angle how much? This opposite angle is must be also 180. This should be how much? 70 degree. Okay. To see its answer now, 70 degree. You solve, use the opposite angle, some property. Now question number 3. If the tangent PA and PB from a point P to a circle with center O are inclined to each other at angle 80 degree, then angle POA is equals to. Okay. Here are the two tangents and center O inclined to each other and angle is 80 degree. Okay. Find angle POA. See, this is 80 degree. POA. This angle you need to find. This is how much? 90. So this line, when you join to this must bisect this angle. So this angle is total 80. Now its bisector is 40, 40. I mean this is 40 and this is 90. 90 plus 40 how much? 110. So this angle must be 70 degree because the sum of all interior angle after triangle is 180. So this property you have to use, and after that your final answer is which angle? POA. Half angle AOB. PA and PB. Okay. Here addition we have done. 90 plus 4. How much? 90 plus 40, 130. So this angle is left 50. Okay. So you see the final answer is here 50. Now question number 4. Prove that the tangents drawn at the end of the diameter of a circle are parallel. Tangents drawn at the end of diameter of a circle. Okay. So this is the diameter and you have drawn the tangents. You have to prove these are parallel. Very simple. If this is a tangent, then this angle must be 90 and this angle is also must be 90. And you use now co-interior angle property. Co-interior angle property, you add these angles and you will get here 180. If the sum of co-interior angle is 180, it means then each line must be parallel. So this property they have used here. See here. Okay. They have used alternate interior angle. This property is also can use. I have used co-interior angle property, that is also we can use. Okay. Now question number 5. Prove that the perpendicular At the point of contact, at the point of contact to the tangent to a circle passes through the center. Okay. Perpendicular at the point of contact to the tangent to a circle passes through the center. Okay. See, let us consider a circle with the center O and the AB is a tangent touches at P. Okay. Now you draw it on this perpendicular. We have to prove that the line perpendicular to AB at P passes through the center O. We shall prove this by the contradiction method. Means we have to use here first contradiction method. We are supposing that the line perpendicular is not passing through here. Perpendicular line passes through here, anywhere. Okay, we suppose that. Okay, so let us assume that the perpendicular to AB at P does not pass through the center. Let it passes through the another point O dash. Join OP and O dash P. Okay. Both line you join as perpendicular to AB at P passes through O dash. Therefore, O dash PB, O dash PB must be 90 degree. Okay. Now, O is the center of the circle and P is the point of contact. We know that this line, you know that very well. This line. We know that the line joining the center at the point of contact to the tangent of the circle are perpendicular to each other. Okay. Means the line which passes through the center and touches to the tangent, the line is also perpendicular. Means that this statement is true. Okay. So this is a contradiction. Two angles at different points, neither possible to be 90 degree. Okay. So this equal to this means this angle and this angle both are now 90 equal. It means this equal to this. If this happens, then what you say? Means the point must be coincide on two. So from the figure, it can be observed that this angle is smaller. But if you want to this put equal, not possible. If only possible when the Q dash P is coincide with OP. Means the O dash point is must be coincide to O. Then it possible. Okay. Therefore, the perpendicular to AB through P passes through the center O. Now the next question, number 6. The length of the tangent from a point A at a distance of 5 centimeter. Length of tangent. Okay. The length of tangent from a point A at a distance 5 centimeter from the center of the circle is 4. Okay. This is your tangent and distance 5 centimeter from the center of the circle. The point A is how much? 5 centimeter and from here 4 centimeter. Now you need to find this, find the radius. Simple, again you use the Pythagoras theorem. 5 square minus 4 square, you will get 9. 9 is square root, you will get 3. It means your radius is 3. Okay. Now question number 7. Two concentric circles are the radii. This find the length of the chord of the larger circle which touches the smaller circle. Which touches the smaller circle. Okay. This is your smaller circle. This is your larger circle. You find this chord length. Okay. Now you know this how much this is your radius and it is also given in the figure, means in the question how much it is 3, and the bigger circle radius how much it is 5. You know that any line drawn from the center to the chord, it is perpendicular, and another theorem is here applied. This line works as a tangent for the inner circle, so in this line when you join to the center, it's also perpendicular to this, means contact point of this line when you join to its center of inner circle, then it also perpendicular. If this is perpendicular, it means this is a right angle angle. Here it is right angle angle. This is a 3, this is a 5, then this must be 4. Use the Pythagoras theorem. Now if this portion is 4, then this portion is also 4. 4 plus 4 total length is 8. Okay. Next question number 8. A quadrilateral ABCD is drawn to a circumscribed circle. Quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD equals to AD plus BC. Okay. You have circumscribed a quadrilateral to a circle. Okay. And you have to prove that AB plus CD equals to AB. This line and this line, its sum equal to this line and this line. Means you understand like this. This line sum and this line sum equal to the sum of this line and this line. Okay. See how we can do this. First, you see that this line is x and this line is also x, suppose, and you know that this work as a tangent. So this line and this line equal, this line equal. Similarly, this equal to this equal to this. Okay. Suppose if I consider it A, then it also this part is A. If I consider this part is B, then this part is also B. Now it means if this part sum A plus B, this part sum is A plus B. Till now here is equal. Now after that here. Suppose that this part is X, then this part is also X, because we know that whenever you draw the two tangents from a point, the both tangent having the equal length from a single point. So this also is X. Okay. So this X and this X, similarly this X. Sorry, if suppose this is Y, then this is also Y. So this sum is X plus Y and its sum is also X plus Y. Means if we add this sum A plus B plus X plus Y, you say this A plus B and X plus Y, means both sides are equal. In this way you have to prove this here. Okay. Now question number 9. Question number 9. In the given figure, xy and xy dash are the two parallel. Okay, xy and xy dash are the two parallel tangents to the circle with the center. Okay. Another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Means here A and here B, it intersect and the contact point is this C. Now you have to prove that AOB equals to 90 degree. See how you can prove this. When you join to this, when you join this to this. Okay, see this triangle and this triangle both are congruent angles. If these are congruent, then this angle and this angle must be equal. Okay, why? You know that this angle equal, opposite of this angle, what is the side? This and this. So this side are congruent. Similarly, this angle and this angle are must be equal. you know that this angle is 90 and this angle is 90. Okay, so now this angle is equal. Similarly, this angle here you see this triangle. How many? So this angle is equal to this angle. If it is now, you know that this is straight line. On the straight line, this angle plus this angle plus this angle plus this angle. How much? Total 180 degree. And you know that this is, you suppose x then 2x. This is by 2y. 2x plus 2y equals to 180. Similarly, x plus y equals to how much? 90. What is x? This angle is x. This angle is y. It means this angle total is 90, and we have proved it. Okay. Now you see how you can prove this. Okay. Now question number 10. Prove that the angle between the two tangents drawn from external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. See, angle between two tangents. Okay, two tangents on from an external point. Suppose here is the external point to a circle is supplemented to the angle subtended by the line segment joining the points of contact at the center. If this line is joining here and this line here subtend angle, that is just supplementary of this angle. Means if this is 30, then this is 150. If this is 60, then it is 120, like that. Okay, means sum of this angle and this angle is 180. Okay, now see. You know that this angle is 90, this angle is 90, 180. Now it means this angle and this angle must be 180 because this is a quadrilateral. Okay, so it means you can say APB plus AOB equals to 180 degree. Okay, now if you want to find APB equals to, then you say 180 minus this. It means now these both angles and sum of any two angle, if you get 180, then you simply say these angles are supplementary angle. Okay, now question number 11. Prove that the parallelogram circumscribing a circle is rhombus. Okay. A parallelogram, the opposite sides equal and parallel. So this is a parallelogram, opposite sides parallel and equal. Okay. So if suppose this is x, then this is also x. If you suppose this is 2x, then this is also 2x. So 2x plus 2x, 4x. Now you know that sum of these two sides also 4x, because you know that any quadrilateral which is circumscribing to a circle, that is, then there a property which is sum of opposite sides is equal. Okay, means this and this equal to this and this sum. Okay. It means this sum is also 4x, and you know that this is a parallelogram. It means this is also 2x, this is also 2x. Okay, and we have to prove this is a rhombus. Okay. Now you know that this is 2x, this is 2x, this is 2x, this is 2x. It means now all sides are equal, you have got it, and this is parallelogram, so this must be a rhombus. Next, what happens this? Hmm. 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 You don't know. Hmm. Okay. A triangle ABC is drawn to a circumscribe a circle of radius 4 centimeters such that the BD and DC into which BC is divided by the point of contact D are of the length 8 cm and 6 cm. BD is 6 cm, DC is 6. Sorry, BD is 8 cm, DC is 6 cm respectively. Find the side AB and AC. Okay, so now you see this is a circumscribed triangle. Here this is BD is 8 cm, this CD is 6 cm. Okay. So now you join this point, then what happens? You see here. This is tangent, this is tangent, this is tangent. Now this length and this length is equal because from external point, the same external point, two tangent you drawn, both are equal. Now this is 6, this is also 6. If this is 8, then this also 8. Now it says that this is x, suppose. Now you know that this radius how much here? 4 centimeter. If it is a 4, you know that this line how much it is? 4. Now you find this area. This base is given and this height is given. So this area equal plus this and this area equal to this. This area of triangle equal to these three triangles are equal having area. The triangle AOC, AOB and COB. Okay. Now you add these triangles area and put equal to the whole triangle area. What is the whole triangle area? You use Heron's formula. Side Heron formula 6 plus x, this 8 plus x, this side, and this is 8 plus 6, 14. Okay. So you see here, these are the sides. Then you find the semi-perimeter. Semi-perimeter sum of all sides. You will get 28 plus 2x divided by 2. You will get 14 plus x. Then you find the area of the triangle ABC. Now area of triangle OBC. How you can find 1 by 2 base into height. Radius 4, 4, 4, and the base 14, 6 plus x, then plus x. Okay. Now after simplify this. Now you add this area and put equal to this triangle area because the whole triangle area equal to the parts of the area. Means sum of the parts of the triangle. Okay. Now you add this part and put equal to this area, and after that simplification you will get your answer. Here is a quadratic equation. This quadratic equation is solved by using the factorization method, splitting the middle term. Now after this you will get here minus 14 and 7. This minus 14 you can't take because the negative is not possible, the length of the side. So you choose the x equal to 7. This is your required answer. Now the side is this and this. Now next question, prove that the opposite sides of a quadrilateral circumscribing a circle subtend a supplementary angle at the center of the circle. Okay. Means this is a quadrilateral. These are the sides and these sides subtend angle, that is supplementary angle. Okay. Quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. You see here, when you join this, 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 and this, and this, this, these are the contact points, so they are making a 90, 90, 90 degree angle. Now you see that this is external point, this is external point, this is external point, this is external point. Okay. For this is external point. Now you see that these two triangles are congruent triangles. If these two triangles are congruent triangles, it means 7 and 6 are equal, and similarly 8 and 1 are equal, 2 and 3 are equal, 5 and 4 are equal. It means in place of, first you know that you can add this sum, you will get 360. Now one thing you notice here, in place of 8 you can write 1 angle because this angle, I am taking here only this triangle, means this triangle be considered much more, and this triangle. Why? question is telling that sum of opposite two sides. So these are the two opposite sides I have chosen here. Okay, these two sides, this one side and this one side I have chosen. So we have to get all the values in the terms of 6, 5 and 1 are 2 angles. So 8 and 1 are angle equal because these are common. Similarly 7 and 6 are equal, 2 and 3 are equal, 5 and 4 are equal. We know that the property of the angle, sum of all angle at a point is 360. Okay. So you apply here, we have applied, okay. And I have told you there the one, see here. On this 8 what I can write 1, on this 3 what I can write 2. It means angle 1 how many times? 2 times. Angle 2 how many times? 2 times. Angle 6 2 times you can say. Angle 5 you can say 2 times. Okay, so these are the 2 2 2 2 times. Angle 2 and 1 2 times, so you can take the common 2. If you want to 2 times you can write here. This is the first line I have told you there. After that you can take the 2 common, so you say angle 1 plus 2, and similarly here angle 2 you take a common and 5 plus 6. Okay, now you divided by 2 you will get here 180. After that you say that angle 1 plus 2 how much? AOB, and 6 plus 5 you say DOC. Okay. Now you see that this sum of two angle is 180. It means these both are angle are supplementary angle. Okay, thank you.